review some word problems with your parametric equations. And then tomorrow we'll probably do 2 more word problems just so they get comfortable with those. And then we're also going to do your chapter 8 review, which is already in this packet for you. So if you were to look at those and if you wanted to start any of those tonight, you certainly could, just to make sure you're good and comfortable. Quizzes look great. So just don't forget that content because you'll see that on your test again here. All right, so calculators first. Can you guys make sure you are in degrees? So you're going to hit mode and you're going to make sure that you have degree highlighted, because with these parametric equations, you're going to do sine and cosine functions again. Okay. So homework assignments for this week, you have 1 textbook assignment. The first 2 questions are real quick and easy. The second 2 are quadratic formula ones that take a little bit longer. And then a review assignment and a test. I also left in there, in case you want it, it's optional and it says optional. There's a chapter 8 practice test too. So if you want to do it, you can. It certainly doesn't hurt you, but it does say optional on it. And I figured why delete it in case, you know, any of you want extra practice. So just in case. Okay, so these are going to be all your scientific based problems that deal with those parametric equations. And a lot of these will get into the projectile types. So your opening exercise is a really easy one just to kind of get you thinking here. And what this is going to ask you to do is just find your initial horizontal and vertical velocity of a stone that is kicked with an initial velocity of 16 feet per second at an angle of 38 degrees with the ground. So because this is initial, super quick and easy. So formula for horizontal. And again, these are not formulas that you have to memorize. So formula for horizontal is going to be x is equal to the magnitude of your velocity times the cosine of theta times t. Okay, and if t is never given, you can always just assume it's a 1. So in this particular case here, I have an initial velocity of 16. So this would be equal to 16, and don't worry about the absolute value bars because this is already positive anyways. And then we're going to do cosine of 38 times 1. You can always just assume it's 1 if it's not otherwise stated. Okay, so that goes right in your calculator. And I guess I didn't specify where to round, so nearest whole number is fine for these. Everyone getting an answer of 13? Perfect. So 13 for your horizontal. Nice, easy initial example. All right, next we're going to move into your vertical velocity. So the only way that the vertical is going to change in this regard before we introduce your projectile problems is that I'm going to have a sine function instead. So I'm going to do the magnitude of my velocity and then times sine of theta and times my time. So we have here a y equal to, and my velocity was 16 feet per second times the sine of 38 degrees. And again, you can assume 1. Okay. You're going to throw that right in the calculator. And I got a solution of 10. You guys agree? Awesome. So y is equal to 10. The initial example like this right here is just like your homework problems from your textbook, 11 and 13. So this is a nice, simple little example. Okay, so if you want to make note of that, just so you know, you can refer back to these nice, easy formulas, you know, for those 2 problems. All right, I wrote a big note in here. So what we're going to get into now are your projectile problems. So horizontal velocity is unaffected by gravity, but vertical velocity is. So what you're going to have here is the addition of a second part of this formula that pertains to your gravity. Now, you're going to use different numbers based on what unit is contained in the problem. So if your problem has meters, you're going to use 9.8 meters per second squared. And again, you don't have to memorize any of this. And if your word problem has feet, you're going to do 32 feet per second squared. Okay, so you're going to use either or. And again, all you have to do is carefully read through the units that are given in your problem. Okay, so when we do an actual projectile problem, which is what you're getting at right here, what you're going to do with your formula for y is you're going to add these values on here, where h just stands for whatever initial height you happen to be at. If there's no initial height stated, you can assume it's 0. I'm going to say assume h equals 0 if no height stated. So if none is stated. Okay, so your motion problems with the projectiles. And if you're a picture person and you want to draw some situations, you can certainly do that too. So everything that's up in your box here, you'll see that those formulas on the left are on the formula sheet I gave you last week. So again, it's not anything you have to memorize for your test or obviously for your final exam either. All right, so let's jump in and start one with a projectile. So a football player is going to kick a ball with an initial velocity of 40 feet per second. So that is that V value that we just identified above. So I know the V is equal to the 40 feet per second. Next, I gave you an angle of 40 degrees. So this is theta. And then with the horizontal. So the first thing you want to find is the horizontal position of the ball after 0.5 seconds. That is T. So your equation for a horizontal position is, and I tried to give you enough space so you can kind of keep these organized. X is equal to, so I'm going to do the magnitude of my velocity, and then times cos, and then theta, and then times T. And I believe we have everything in here, so all you have to do is just type this now. So X would be equal to, my velocity was 40. And then I'm going to go cosine. And then I'm going to go 40. And then my value of time was 0.5 seconds. All right, we can round this to, for accuracy, let's go 3 decimals, okay, guys? Just so that you've got a nice accurate answer to kind of work with. So you're going to type that in. So 40 cos 40 times 0.5. Did everyone get like 15.321? Awesome. So we have X equal to 15 point, what did I say? 321, sorry, 321. And if you want, this would be in feet. Okay. All right, letter B. Now you are going to find the vertical position of the ball after 0.5 seconds. So now I'm going to use my formula that is dependent on the gravitational pull. So I'm going to go y is equal to, and this is right from your box. So magnitude of your velocity, and then times the sine of theta times t plus 1/2 times g t squared plus h. So we have to kind of put some values into this now. So I have y is equal to, the first part's going to be the same as what we did up there. So I have 40 sine, and then I'm going to go 40, and then t is still going to be 0.5 seconds. And now I'm going to go plus, and I'm going to go 1/2, and now I need to go up and I need to find the g. So for this particular case, your unit of your question is which one, feet or seconds? I'm sorry, feet or meters? Feet. So which one are we going to use, the 9.8 or the -32? Yep, -32, good. So again, you don't use both, you just use whatever the question happens to have. And then the t value, so I have 0.5 squared. And again, your initial height, you weren't given anything. So you can assume that that is 0. Because it's gravity. You know, it's a physics concept, and I can't really speak to it too much other than whenever you have that gravitational pull, it's always a negative value. So it's always going to be negative, but again, please defer to your science teacher for a little bit more on, you know, that concept. Like, I know this is something you guys talk about next year, but you take what chemistry this year? Bio, okay, oh yeah, obviously, I knew that. Bio, you don't do any math whatsoever, do you? No, but you'll do a lot of problems in physics with, like, they do a lot with the potato gun and like projecting the potatoes onto the field. And I know I've seen them out there doing labs and whatnot, but it's always going to be that negative value. All right, so we've got y equal to, and you're going to type all that in the calculator, and we can round this off to the nearest, yeah, we'll go 3 decimal places again. Everyone get like 8.856? Perfect. So 8.856. Okay, next part. And this pulls back a skill that you've used in the past. You need to find the maximum height of the ball. So to find the maximum height of the ball, what you're going to do is you are going to take the derivative, just like you did in preparation for your midterm, of your y equals equation to find the time that this occurs at. So to find t. And then you will sub it back in, just like, again, you've kind of done in the past. But you're just extending this to a word problem now. All right, so my equation for y. So I have y is equal to, I'm going to go 40 sine, and now we're solving for t, so you're going to put it back in, of 40t. And now next, if you want to just consolidate this, obviously 1/2 times negative 32 would just be minus 16t squared. And plus 0. Okay, so you're going to take the derivative, just like you did, again, you know, back in January when you were preparing for your midterm. So when you take the derivative of 40 sine 40t, the derivative is always what's included in front of the variable. So my derivative is going to be 40 sine 40. So I have 40 sine 40. And then for this next term, power comes down in front and gets multiplied. So this becomes a negative 32t. And you guys remember what happens with the derivative of a constant? It goes away. Very good. So this allows you to solve for t. So now what I do is I add the 32t over to the other side. I'm just going to show this just so that you know, if you look back at it, you know, it's just this easy. So plus 32t, and I get 32t equal to, and then I have 40 sine 40. Solve for t. So I'm going to divide by 32, and then divide by 32. And again, you just want to be careful with your rounding because we're not done yet. So whatever you choose to round this to here does impact the next part of your answer. So I want to go 3 decimal places again. Everyone get 0.803? Perfect. So 0.803 seconds. That is when the maximum occurs at. It is not the actual height though. So to find the actual height, what I finally finish with is I now sub in. Okay, so I'm going to replace that where the t is. So I'm going to replace it here and replace it here. Do this though, just because I foresee maybe there'd be some confusion. Why don't you write sub into original? You don't sub it back into the derivative. So I get y is equal to, I'm going to go 40 sine, sorry, just write a little small, of 40 times 0.803 minus 16 times 0.803 and plus 0. You don't need to put the plus 0 unless you want to. All right, and then that is going to be the maximum height of the ball. All right, so 40 sine 40 times 0.803 minus 16 times 0.803, obviously plus nothing, is equivalent to 10.329 feet. And that is your final answer for part C. How are we feeling so far, okay? Good. Yep, so when you guys see maximum, because we'll do another one of those in a minute, maximum means derivative. Yep, so derivative of your y equals equation, and then you use that to figure out when the maximum height occurs, sub back in to find the actual height. All right, I'm sorry, this problem continues on to the back. So you're gonna need to recopy this equation, sorry. I couldn't fit it all and I didn't want you to squeeze it. All right, the length of the time that the ball was airborne. You know, so you're kind of thinking of it like this. So our equation was y was equal to 40 sine 40 t minus 16 t squared, and then plus nothing, which I'm not going to keep writing. Okay, so I want to figure out when it's going to hit the ground. So I'm going to go 0 equal to, and we're going to go 40 sine 40 t minus 16 t squared. Okay, so you want to figure out your values of time. So if you look at these, you actually have a GCF here. So you're going to take out your GCF. So I have a t, and then that would leave me with 40 sine 40 minus 16t. All right, and we're going to just solve both sides. I need to adjust my picture a little bit. Well, it occurs at 0, so it's just up there though. So t equals 0. And then you're going to find your other one as well. So I am going to go 40 sine 40 minus 16t equals 0. So 40 sine 40 minus 16t equal to 0. So you're going to add your 16t over, and then we're going to divide this out. So equal to 16t, and divide both sides by 16. Divide by 16. And for consistency, let's carry this out far as well. So 40 sine 40, then divided by 16. You guys give me the answer yet? Yes, thank you. That is correct. 1.607 seconds. Awesome. Yep, so we've got both of those right there. So then last part of this question, you're going to find the horizontal displacement of the ball. So horizontal means we're going to pull back the horizontal equation, and you're going to sub in those values for t. So we're going to sub in t equals 0, and the other answer we just got, which was t equal to 1.607. And the horizontal equation is x equals, and it was 40 cos 40, and then times t, where this one t is 0, and then the other one t is 1.607. So we're going to just get both of these answers and subtract them. Just figure out the horizontal displacement. So obviously your first one is just equal to 0. And then your second equation, this one does work out. This one's a decimal. Let's see, 49.241. So 49.241. So therefore, to find your displacement, what you're going to do is just subtract those, which obviously because it's nothing, you don't really need to show that. So 49.241. Was it feet? I forgot. Thank you. So feet. Okay. All right, new scenario. Next, you have an archer who is going to shoot an arrow at a target 70 meters away. Okay, so I'm going to start and I'm going to write you just a little note just in case. So meters away, this refers to a horizontal distance. I'll put an H on that. You have an initial velocity of 60. So that's that magnitude of V again. So we know, again, just a couple little side notes here in case you want them. That's going to be that value. You have an angle of 4.8 degrees with the horizontal. So theta is 4.8 this time. And it says the bow is held 1.4 meters above the ground. So this is going to be a vertical. So this is going to be your initial height, actually, because it was given to you this time. So initial height is 1.4. Okay. So how far off the ground will the arrow be when it hits the target? So we have to find your time value again first. So we're going to do your horizontal equation to begin. Solve for t and sub it back in. So horizontal, again, just to try to give you nice, thorough notes. Your horizontal equation is x is equal to, and you're going to go v, and then cos theta, and then t. And again, you should have all of this information except for just one variable. So we are going to shoot 70 meters away. So that's the horizontal value. Equal to our velocity was 60. And cosine of 4.8, and t is what you're solving for. Okay, because then you'll be able to sub that into your second equation. So you're going to take this and divide now. So divide by 60 cos 4.8. And again, divide by 60 cos 4.8. And just be careful how you round these because it does impact your final answer. So if your answers vary slightly on the homework, don't worry about it. It's just all going to be based on your rounding. All right, what do we get on this one? 1.17. Awesome. Me too. And that is seconds. And again, you need that information to proceed further to your next part. So now how far off the ground is the arrow going to be? So I'm going to do my vertical next. And you're going to refer back to that formula because again, you don't have to memorize it. So I'm going to go y is equal to, I'm going to go v, and then sine, and then theta t, and then plus, and then 1/2 gt squared plus h. What makes this problem different is this time you are not using feet. What are you using instead? Meters. Yep. So we've got to use the other number that was stated. So you have y equal to your velocity was 60, and then sine, and then 4.8. The time value you just found, it was 1.17. plus 1/2. G, you are going to use negative 9.8 instead. And then T is 1.17 squared. And then do you have an initial height this time? I think we did. Yes, 1.4 meters. And then there you go. That all goes in the calculator, really nice and slow. Kind of a lot to type. And that is your solution, because you did not have to find a maximum this time. I think I gave you one on the next problem instead. All right, so throw that all into the calculator. I got 0.57 meters. So y is equal to 0.57 meters. This is meters instead of feet. Okay. How do we feel with meters, okay? And again, just like pay attention to the unit. I know sometimes it kind of all gets thrown in there and you kind of forget to look for things like that. All right, next scenario. This time you have a toy rocket that is launched with an initial velocity of 80 feet per second. So that's going to be my V. And we're back to feet again. And I have an angle equal to 80 degrees. And it says how long until the rocket is 10 feet horizontally from its starting point. So horizontally, is that x equals or y equals? X equals, yep, good. So the equation that you're using is x equals magnitude of the velocity times cos theta t. And you're going to sub in, and again, you should only have one unknown, otherwise you get stuck, obviously. So we know we want to be 10 feet away. So 10 goes on the left. And this should allow us to solve for t. So I have 80 cos 80 t. And now divide it over, and we are good to go here. So divide by 80 cos 80. And again, the reason I keep writing that out is because you don't want to round this ever. So keep this exact till the end. So this is 80 cos 80t. So 80. And t is equal to, and this is going to be in seconds. All right, did we get an answer of like 0.72 seconds? Perfect. 0.72 seconds. Good. Okay, so part B, another one of these again. What is the maximum height of the rocket? So what do we need to find to do a maximum? Derivative, yep, absolutely. So you are going to do the derivative of y equals equation to find when it occurs and then sub it back into the original. So derivative of your y equals equation to find when it occurs. And then sub into original. Because again, that's where most of the mistakes happen. It's like everyone just forgets and they sub it back into the derivative instead. So then sub into your original. Okay, so our equation in terms of y equals here. So we have y is equal to, information up here, 80 sine 80 t plus 1/2. I got to find g now. All right, what's our unit for this question? Feet. Yep. So which one are we using? The 9.8 or 32? Yep, very good. Negative 32. T squared. And initial height, we don't know. If you want to put 0 in here, you can. Up to you. So we need to now do the derivative. So I'm going to do the derivative of my y equals equation. So the derivative of 80 sine 80t is just the coefficient in the front, which would be represented by 80 sine 80. Because that's just a number. It's just we didn't do any calculation work to it. Okay. So I'm going to multiply this out. This is obviously negative 16t squared. Power down in front. So 2 times negative 16 is negative 32. And then subtract 1 off your power. And then derivative of 0 is obviously 0. So solve for t. So I have 32t equal to 80 sine 80. So 80 sine 80. Divide by 32. Divide by 32 again. And t is equal to, I got 2.462. You guys agree? Perfect, 2.462. That is the time the maximum occurs at. It is not the actual maximum height. So now you're going to sub it back into the original, not the derivative. I'm trying to stress that because it happens a lot that students forget. So sub into original. It's the same mistake that got made during the year. So we're going to go y is equal to, just have to write kind of small because these get big. I have 80 sine 80 times 2.462 minus 16 times 2.462 squared plus nothing. Again, you don't have to write the plus nothing. I'm just putting it there so you know our height was a 0. All right, solution should be 96.985 feet. As an agreement? Oops, sorry. 985 feet. Okay, so maximum is going to be your derivative. All right, the next one's nice and quick. All right, next scenario. You have a bullet that is shot at a target 70 meters away. So again, this is a horizontal distance. And initial height of 1.5 meters. So this is my H there. And then its initial velocity is 50 meters per second and the angle is 10 with the horizontal. When is it going to reach the target? So that's going to pertain to your horizontal here. So to do the horizontal, you're going to go back to x equals. All right, so horizontal. So horizontal equation, and then you want to solve for t. Solve for t. All right, so we have x is equal to, I'll write it first, I guess, and then velocity, and then cos, and then theta t. And then we knew we were 70 meters away, equal to, velocity was 50, and cosine of 10, and t. Okay, so you're just going to take that expression and divide it over. So divide by 50 cos 10 and get an answer. So divide by 50 cos 10, divide by 50 cos 10. And you're going to use this below. So again, just be careful of your rounding. All right, so t is equal to, did you guys get 1.422 seconds? 22 seconds. Okay, so how high off the ground will this hit? All right, so now I'm going to sub this into my y equals. So we're going to go y is equal to, I'm going to go, my velocity was 50, and then I go sine And then I'm gonna go 10. And my time was 1.422 plus 1/2. And what is the unit this time? Meters. Okay, thank you. So negative 9.8 instead. And then times 1.422 squared. And I think we had an initial height, didn't we? Yes, thank you. 1.5 meters. And then you're good. All right, all that into the calculator. I'm sorry, I should have warned you to write small on that one. All right, so y is equal to, and this answer will be in meters as opposed to feet. Y is equal to 3.94 meters. So 3.94 total meters. Okay. How are all those so far? Good. Now, number 5. There's something that's different about this one. I don't know if you're going to catch it or not, but you're going to have to do something with one of these numbers. So we have an airplane that is flying at an altitude of 2,800 feet, and they're going to drop supplies to people on an island. Your picture person. You've got a plane flying up in the air, and you're going to drop supplies down to some people. Again, if that helps. The plane is flying parallel to the ground at a constant speed of 280 miles per hour. So to the nearest tenth, how long does it take before the supplies hit the ground? You guys notice anything with the 280? It is. Yep, you can't do that. So we have to change this. You have to do a conversion. So I'm going to say convert, and you'll see a homework problem that makes you do that too. And I think we're going to do another one of those tomorrow. So convert from miles per hour into feet per second squared. You want feet per second squared because that's what that G value refers to. Okay. Do you know how many feet there are in a mile? There are 5,280 feet per mile. I guess we sometimes assume that's common knowledge, but that's usually on your Regents formula sheet. You guys had those conversions listed at the top. So I want to do 280 and then times 5,280 and then seconds squared. So you want to think of it like this. There are 60 seconds in a minute and it's squared, so you're going to do it twice. Okay. All right, this does not work out nice. This is going to be a decimal. I think it ends in like 0.667. Does it? Yeah, so I am going to round this just because it gets, you know, annoying to keep writing the fraction. So just so you know, again, like answers do get thrown off a little bit when you round them. So this conversion right here was 410.667, and that is equal to your velocity. Okay. There's one other thing that you might notice is not here. You notice there's no angle provided. There's no angle provided because the people in this plane are not exhibiting any force whatsoever. All they're doing is pushing something out of a plane. So your angle is actually equal to 0. Because there is no force, only gravity. Okay. So how long does it take before the supplies hit the ground? So we'll start with the first equation, see if it brings us anywhere, and if not, we'll write the second one out. So my horizontal that we've been using is x is equal to, And then we would have velocity, and then cos, and then theta times t. I don't know this. My velocity we know is 410.667 cosine of 0, and then t. You guys remember that cosine of 0 is 1? It's okay. If you don't, you could type it in anyways. So basically, what happens with this is you can't solve it. So you're essentially kind of stuck. So you're going to resort instead to your y equals. So our velocity is 410.667 sine of 0 and t, which is again unknown, and then plus 1/2. And what was our unit here? We had the feet, didn't we? Yeah, so we had the feet, so we're going to go 1/2, and then we're going to go -32, and then t squared plus 2,800 feet. Okay, so coming to the end, actually, what is the sign of 0? 0. So that's gone. So I get y is equal to -16t squared plus 2,800. All right, bump that to the other side. We get 16t squared equal to 2,800. And you can divide and square root this now. Almost there. So divide by 16 and square root. And obviously you're not going to use a negative answer. So divide by 16, and then you're going to square root this as well. So I guess I'll show this just for in case you look back at this. All right, what do we get? I got 13.23. We in agreement? So 13.23. Okay, and then last. How far do these people have to travel horizontally? So now you can sub that in right here. And that's kind of why I wrote that over there too, so you have it already. So x is equal to 410.667 cos of 0 times 13.23. And again, this answer is just going to depend on your rounding. I don't know what I did with here. I got 5,000. I don't remember how I rounded this initially. 5,432.714. Okay. But again, when you're checking answers and whatnot, just be aware that those do get thrown off significantly based on rounding. Okay. How are those word problems for now? Pretty good? Okay. So we'll stop there for now. Tomorrow we're going to do, we'll do another conversion one just because I know that those tend to be a little bit tougher. We'll do 1 and 2, and then we're going to do your chapter 8 review as well. If you want, you're welcome to take your last 10 minutes and start and work on some of these because we're going to go over them tomorrow anyways. Well, up to you guys. Do you have Spanish to study for again today? Tomorrow? Every Friday without fail, right? Every Friday.